Good morning.
Very, very good evening to you. Good evening to you, Amir. How are you doing?
Good, thank you. Good to see you again.
My pleasure. Are you able to see me and hear me?
Yes.
Great. So,
Yeah.
so Amir, it is evening 4:30 for you, right?
Yes. 4:15. Yes. No.
4:50. Great.
Yeah.
So this is a very interesting topic, Amir. I'm particularly happy on the topic that we have finally decided upon.
Yep. Sure.
We expect some.
That's interesting topic. I'm interested to see what others have to
Yes.
say because they are coming
Yeah.
from industry, and I
Yeah.
will basically discuss how we implement such experiences in our classes here.
Yeah, exactly.
How many people from United States are joining?
Amir, a large number of participants will be from India.
Uh-huh.
Will be
Okay.
from India.
Mm-hmm.
I had close to 55 registrations,
Uh-huh.
and I sincerely believe a good number will turn up. A good number will turn up.
Mm-hmm.
But what we intend to do is, as I mentioned, we would like to make a report of the discussion and then take it forward.
Mm-hmm. Okay, great. So I have a question not related to this, but
Yes,
you
yes,
remember
please.
last year I wrote a piece for you?
Yeah.
Oh yeah. So is there any link to that I can share with my colleagues, or was it that something that you sent via a newsletter?
I can. It was made part of our website, explore space360.com. Can I send that link to you perhaps after this?
Sure. Of course, that would be great.
Yeah. I'll be
Thank
happy
you.
to do that.
Sure.
Thank you. Thank
So
you,
I'll
Amir.
be
Thank you.
around and waiting for the meeting to start.
Yeah.
I'm reviewing my notes.
Thank you.
Yeah, sure.
Good morning, Ram. Good morning, Ram. You will have to switch on your mic. Ram, are you able to see me?
Yes.
Yeah. Now I'm able to hear you. I'm able to see you. Thanks, Ram. Thanks for joining. I just had a few words with our friend Professor Amir Saidi, who has just joined. Amir, if you're there, this is Mr. Ramaswamy.
Hello,
Ram,
sir.
Mr. Amir is a great friend of ours.
Hi, good morning.
Good evening. How are you?
Yes, good. Thank you so much. Looking forward to hear your insights on this topic.
Sure. We are also eagerly waiting.
Participants are signing up, so we hope to start very soon. Thank you, Ram. Thank you, Amir.
Sure. Thank you.
Welcome to Jaideep. Jaideep, a very good evening to you.
Good evening.
Very good evening. Thank you so much for joining. The whole program started with the idea that you gave. Thank you so much. Ram, I'm very pleased to introduce Dr. Jaideep Mukherjee to you. Jaideep, that is Mr. Ramaswamy, consultant who connects industry and academia based in Chennai.
Great.
Good evening. Good evening, sir.
Good evening. Good morning to you, right? It's very early in the morning.
Yes. Amir has also joined. Amir, very good evening to you, Amir. We have Jaideep here. We recollect the program that we made for the students of UC Davis, the school students, with Jaideep a year back.
Yeah,
I remember. How are you?
Yeah, good. How are you?
Good.
Great. Good to see you again.
Yeah.
We welcome Professor Subhash Risbut from University of California, Davis. Professor Risbut, thank you so much for joining. I think Tim should be joining any minute. We will have the first round where each speaker speaks, and then question and answers, and then discussion. So we should be starting in a few minutes. Jaideep, there were some questions on James Webb Space Telescope also. So I have told them that this will be on a different topic, perhaps at a later date. With your convenience, we can have something exclusively on James Webb Space Telescope.
Okay.
Hello, DV, Jaideep. Hi.
Yeah. How are you?
Fine. I'm here.
Very good evening to you, Professor Subhash Risbut. Good evening. Thank you so much for your interest, enthusiasm, and encouragement. That's Mr. Ramasamy there. Ram, that's Professor Subhash Risbut.
Hello, Professor Ramaswamy. Yeah.
Good evening, sir. Good evening.
Hi.
We expect Tim to join any minute.
Mm-hmm. What time is it in India right now?
It's going to be 5 a.m. It's 4:58.
Oh my gosh, it's way early for you guys.
Thank you.
But you know, the weather in Davis these days is just like the hottest day in Chennai, probably, because we're reaching temperatures of 102 and everything, Fahrenheit, of course.
Oh, okay.
So we're waiting for cooler weather to come.
Okay.
But Chennai is not affected by all the flooding I heard about in Mumbai and Pune and Delhi and all that, right? Chennai has no problem with flood.
Not so far, Professor. But October and November, we expect very heavy rains. Hopefully, we manage without flooding. But October and November are going to be tough for us.
Mm-hmm. Yeah. Well, weather we cannot control, that's for sure.
Yeah.
So is Mr. Ramaswamy in Chennai also?
Yeah.
Yes,
I'm from Chennai only.
Oh, okay. Yeah. Yeah.
We certainly expect much better times for the Indo-US trade and commerce. We all know that it is passing through a very what to say, challenging times. We feel that the relationship between particularly commerce, India and United States will be able to weather this storm. and move ahead and forward.
Yeah, let's hope it blows away soon. And
particularly in the context that about 3 weeks back or 4 weeks back, we had a very successful launch of the NISAR Earth Observation Satellite, which is a great collaboration between NASA and ISRO. They took about 10 years. The whole thing was developed at JPL, California, and then it was moved to India, and we had a very successful launch on 31st July. On 31st July, so the launch took place in India. So those are the positive things that are happening in the collaboration between India and USA, with particular reference to the space industry.
So do you know about the person at Jet Propulsion Lab? You said JPL in Pasadena, right?
Yeah. The whole structure was built at JPL, and then it was moved from JPL to the Bangalore airport, and then from Bangalore is in Karnataka state, and then the launch pad is in the state of Andhra Pradesh, and then it moved from Karnataka to Andhra Pradesh, and we had a very, very successful launch. That was on 31st July.
Very good to hear that. Yeah, that's fantastic. 31st July, just a month ago. Yeah, okay. Yeah.
It also unfurled the largest antenna in space.
Oh, I see.
We have Tim joining there.
Okay, Tim is here.
Tim, very good evening to you, Tim.
Good evening. Good evening.
Hey, Tim. Hi.
Hey, Subhash.
Hello.
Hey, Amir is here too. Wow.
Hi, team.
Yeah, Amir is here.
All right.
My colleague Amir is in our department. Yeah.
I know
Tim,
him.
we have
I've seen
Dr.
him before.
Jaideep joining from Florida, Mr. Ramasamy from Chennai, along with our friends Professor Rizwood and Amir. So thank you, all distinguished speakers. So with all speakers in, we will now start the Zoom session formally. On behalf of Explore the Space, a very good morning to participants in India. It is 29th August, Friday, for participants in India, and a very, very good evening to the speakers and a few participants who are expected to join from United States of America. A very good evening to participants from United States of America. It is 28th August, Thursday for you. We are going to discuss on a very, very interesting topic, where we are going to discuss on how we are going to enhance the involvement of students in the space industry, with the help of competitions and internships. That's a very interesting topic, given the fact that there are an increasing number of demand, if I can say so, for talent and innovation in the space industry. With those words, I take pleasure in welcoming the panel, Dr. Jaideep Mukherjee, Director, NASA Florida Space Grant Consortium, Florida. Welcome to you, Dr. Jaideep, sir. Mr. Ramaswamy, Consultant, Industry Academia Partnerships, Chennai. Welcome to you, Ram. Professor Subhash Rizwood, Distinguished Professor Emeritus, Material Science and Engineering, UC Davis College of Engineering. Welcome to you, Professor Subhash Rizwood. Mr. Tim Dyer, Executive Director, Frelog, United States of America, and President, MATSI Innovations. Welcome to you, Tim. And Professor Amir Saeedi, Assistant Professor, Department of Material Science and Engineering, UC Davis College of Engineering. Welcome to this distinguished panel. Now I request Dr. Jaideep Mukherjee for his initial remarks, please. Over to you, Jaideep.
So I don't know what you're doing over here. Am I just going to talk for a few minutes?
Yeah.
What is the setup?
We would request each of the panelists to talk for about 5 to 6 minutes, and then have some questions, and then have the second round of discussion.
Okay, I thought it was something different because I had a presentation ready. If we just 5 seconds, what I'll say is that the space economy is actually the biggest economy in the world right now. The global space economy. Now, I don't have the numbers with me because it's on my slides, so I can't give you numbers right now. But what I wanted to tell you is that I'm off now because I'm not looking at my presentation. But
Jaideep, sorry to interrupt you. You are welcome to make your presentation.
Yeah, I'll just quickly go over it. If you can give me
yes, please.
If you allow me to share my slides.
Yeah, yes,
can
please.
you see? Hold on. Okay, you have to give me permission, please.
Yeah.
To share.
Yeah.
Okay, do you see it?
Yes, we are able to.
Okay.
Yeah.
I won't take too much time with the presentation, but I wanted to give you some key facts and figures, and then you'll understand why all the other panelists are talking about this connection of industry and academia. So just quickly to let you know that in 2024, the global space economy reached about 613 billion. That's a 7.8% increase from the previous years. But the most interesting thing going on over the last 5-6 years is a dominance of the commercial sector. So look at that. The private sector revenues made 78% of the 613 billion. The government was going 22%. That's a big change over the last 10 years. And that's what's actually driving the economy across the world. In the United States, US has invested 77 billion in security and civil. So apart from NASA, we also have the Space Force, you have the Department of Energy, a lot of other agencies which are connected with the space industry. And then the estimate for 2025 is that it will grow to about 650 billion or 450, depending on whose report you read. A regional snapshot, North America, of course, leads the market because there's strong public investment and private investment. But the Asia Pacific region is the fastest growing region. Europe continues growing via scientific and defense collaboration. That's the difference. Europe is focusing a lot on science and defense. While India, as you see, has values is around 8.4 billion, and is expected to rise to 13 billion. So India is going to play a big role in this global space economy, and that's why we have to figure out a way of connecting students to industry so they can contribute more to this economy. So what are the growth drivers and trends in the economy? Commercial expansion, this is the biggest thing. Talking about satellite, Earth observations, communication, we call it downstream applications, looking down, communication, navigation, and so on. And upstream would be the launch vehicles, building satellites. And as you see, in the first tab, we saw a launch of every 28 hours across the world, led by SpaceX. So I live in Florida, about 20 miles from Kennedy Space Center, and there's a SpaceX launch almost every other day. So they're almost expecting more than 150 or 200 launches this year. So other drivers in space manufacturing, okay, now whether it's pharmaceutical or semiconductors. In fact, I don't know in India, but in the US, there's a big push for testing semiconductors and pharmaceuticals and microgravity in the space station, in suborbital flights, and so on. And that's focused to become a huge industry in about 10 years. Funding dynamics, the private investment that has really helped the economy. Satellite mega constellations like Starlink and Kuiper, they're good for communication, but they are horrible for the environment. They are, space debris is going to be a major problem. And then there's this trend of large satellite firms merging together. SCS and Intelsat, Boeing and OneWeb, and so on. So here's the outlook. 2024, 613 billion. 2025, it depends on whom you look at, from 450 to 650 billion. But look at by 2030, 2035, it's almost $1 trillion. That is really big. So students now must take advantage of the fact that they have this huge area that they can work on. This is just to give you an idea in the world government expenditures. Now, these are government, not private. As you see, United States is about 73 billion. But look at India. India is pretty well, I think it's the sixth largest with $1.7 billion in government expenditures. That's pretty good. Again, these are for students. If you want to see where you have the space economy output, which is like revenues, manufacturing, and it could be anything from building satellites, electronics. That is the major part. Another major part is information, communication. Then comes government. As you can see, the government investment has risen, wholesale trade, and all the other industries. Well, these are the main big areas where you can see a lot of gross output. This is the distribution of investment. As you can see, again, the US leads, but this is Europe, China, and this is Japan. These are in billions of euros, but it's very similar to a dollar. This is the investment map. As you can see, India is not bad either. It's between 11 to 50 million euros invested in India. This is not government spending, private investments. But here's the most interesting thing going on in the world right now. Look at this ratio of private investment to public. In the US from 2019 to 2021, it went from 7% to 20%. And Europe, it was quite large, 15%. It's about 17% now. But there's a large increase in the private investment, which is driving the global space economy. But what is most important is if you look at the employment numbers and the employment percentage change from 2022 to 32, look at the STEM occupation, 10% increase, as opposed to the others, non-STEM. So being in a STEM field is really, really important right now. I'm going to skip certain slides here because I'm trying, but here's the emerging opportunities in the $1 trillion space economy. Orbital construction and in-space manufacturing. Now, if you want to go to the moon, you don't want to carry robots with you. You want to build the robots right on the moon. Or if you want to do asteroid mining, you don't want to ship robots or launch robots. Build it there. Build infrastructure on the moon. So orbital construction, in-space manufacturing is important. Lunar resource extraction. A lot of the countries are going to go to the moon, especially the South Pole, because they have evidence of water in the floor of the craters in the South Pole. Not water, sorry, ice. So we can take this soil and we can extract the water and get oxygen and hydrogen. We can use the hydrogen for fuel. We can use oxygen for breathing and also for water. So lunar resource extraction is very, very important. AI and robotics, of course, artificial intelligence is taking over everywhere. But there's asteroid mining, orbital maintenance, robotic lunar surface operation. We're doing that a lot in Florida, in my university. Space-based energy production, solar power satellites, fusion, and launch, ride share, and space tracking. So these are the emerging opportunities in a trillion. And I want to give you 3 quotes. One of them is by the US, someone on the US Space and Defense, the Airbus. One of the most things we can do is to continue to invest in talent encouraging young people to pursue technical careers, especially women and underrepresented minorities, to go into fields like aerospace. From Lockheed Martin, I think what we're going to see in the future is space for space. So there'll be services where the value is created. And then finally, a quote from Peter Platzer, who is the co-founder and CEO of Spire Global. And he says, in 15 years, we will have structures in space that are not government-owned, but are commercially owned, commercially operated, and they will be not just for research, but also for tourism. So we are actually talking with a company in Florida, and they're very much interested in building a hotel on the moon. And they've started right now to figure out ways to do it. So the reason I can show you this, there is one slide I want to show, and that will open up the discussion between industry, and that is talent shortages and skill gaps. So the science and engineering workforce challenges, the demand is more than what we can supply in terms of scientists, engineers, technicians, definitely. We need specialized needs, propulsion, advanced materials, AI, space medicine. That's a really incoming field, especially with pharmaceuticals. But here's the problem, the STEM pipeline is uneven globally, okay? And there's a lot of underrepresentation is not good, is bad, because it limits innovation. It really does. And there's an aging workforce and knowledge transfer. A lot of seniors are retiring. There's gaps in mentorship, and we're losing risk of losing decades of institutional knowledge. And I'm seeing that in NASA right now, with NASA's budget being slashed. 20% of NASA folks have retired or taken forced retirement. Now these are seniors. Now, so we can't bring them back again, even if Congress is going to put the money back for NASA, which I know they're going to. We can't bring them back. So we already started losing folks, a lot of talent. There's an international competition for talent, so US, China, India, Middle East. You notice that India comes up everywhere. India is a big player now in the global space economy. Again, visa rules and policies are changing right now, and that's going to have a problem with talent mobility. But here's what I think is very, very important. It's training for the emerging sectors, okay? Space cybersecurity, space traffic management, commercial space stations, in-space manufacturing. These are the really upcoming fields. But look what it requires. It requires rapid curriculum updates. We can't rely on the same topic for the next 4 or 5 years. We have to change every year. And industry-university collaboration. So I'm so glad that you're doing this, because that's what's going to drive this global space economy. It's getting this talent by combining working with industry. So I'll stop here. I won't talk about opportunities right now. I just wanted to give an idea of the global space economy and why we're having this discussion.
Thank you. Thank you so much. Thank you so much, Jaideep. Dear participants and panelists, that's a terrific start for the program. Jaideep mentioned that there is a launch every 28 hours. Every 28 hours, there's a launch. That's a very, very inspiring figure. And Jaideep also mentioned about the horrible aspects of space debris. That's a real cause of concern. And the silver lining was the increase in STEM employment. So thank you so much, Jaideep, for these very valuable insights. Participants, now I request our panelist from India, Mr. Ramaswamy, for his inputs. Over to you, Mr. Ramaswamy.
Yeah, thank you, Venkat. Yeah, I'm audible. Yeah. Good morning to India. Good evening to US. Thank you, Venkat, and thank you, Professor Jaideep, to make a launching pad for my talk, which specifies industry and academic partnerships. Why we should have the industry and academic partnership? What is the reason for that? The universities provide the blue sky and applied research and nurture the talent pool that will shape the future. Industry partners from manufacturing to the creative arts help realize the economic and social impact of knowledge and innovation. See, in today's fast world paced, as Professor Jaideep also told, that the knowledge becomes obsolete quickly and people are getting retired and manpower getting shorter. The shelf life of technical skills is now less than 5 years. And according to a World Economic Forum report, by 2030, over 1 billion of people will need to reskill due to the rapid digital transformation. Everywhere we are talking about digital transformation. In this dynamic landscape, the bridge between the academic and industry is not just important, but it is very essential. So the best way to have the industry and academic relationship is the internship. Internship is the answer to bridge the academics and the industry. Whatever we have in the classroom concept, it should be transformed into real life skills. Helen Hayes, who is an American actress known as the First Lady of American Theater, she says the expert of anything was once a novice. So we should start from there onwards. I would like to give the first 6 important points of advantage, which turns out to be from the internships. Number 1, the internships provide hands-on experience. Best learned by doing, not just by reading itself. You cannot just ride a bike or car driving by just going through the theoretical lessons. You should have the practice. Then only you can have the driving comfort and driving skills. So you have to tackle the real problems, which teaches you how to find the solutions. You will use the professional tools that are standard in your industry. You will learn by observation, working alongside experienced colleagues. See, wherever I go to the college to give talks to the students, I emphasize this is the best period for the students to learn is the colleges by committing mistakes. Internship is an opportunity to learn after mistakes. Point number 2, internship enhances your resume. Yes, it signals the employers that you are proactive in your career. It shows that you have experience working in a professional environment. It indicates you are able to handle responsibilities beyond academics. Additionally, this is not just about listing the internship itself. It is about highlighting specific skills and projects you have worked on during your internship. Point number 3, internships improve skill development. Apart from the technical skill, there are many byproducts which are communication, teamwork, and problem solving. Point number 4, internships can lead to full-time job offers. Many companies use the internships as a way to train and evaluate the future employees. Point number 5, it gives you a competitive edge in the job market. The achievements and skills you have gained during your internship can be highlighted during the interviews, showcasing your practical capabilities. It demonstrates that you have been exposed to the pressures of a real job, which suggests you can handle stress and responsibility. Point number 6, it will help you to understand industry expectations. This is a very important one. Internships immerse you in your chosen field. You will learn the importance of staying updated with the latest technology trends. You will realize the collaboration and adaptability. You will get a sense of pacing and delivery standards that your industry operate with. It also talks about other advantages. I'll just highlight and rush through that because let us see the other things in the next session. It bridges the gap between theory and practice. It gives insight into career interest and goals. Internships offer networking opportunities. Internships confirm career direction where you have to move around. Provides mentor benefits. This is a very important point which Professor Jaideep also mentioned. The senior mentors are getting retired. We have to invest. Internships teach professionalism and work ethics. Internships help understanding workplace culture. It builds confidence in your abilities. This is very important. You are building your sense of self-assurance and competence. Internships offer exposure to the real world problems. It encourages your personal growth. So we can go on talking about internship more and more. Let me see it in the second round. So with this, my final thoughts, you have a renewed sense of excitement about internships. They are just a line on your resume, but a playground for your growth, a launching pad for your career, and sometimes a mirror reflecting your true professional desires. Take these insights, let them marinate, and you are ready to step into the world of internships. Do it with confidence. I will talk about the internship opportunities available in India in the next round.
Thank you.
Thank you.
Thank you.
Thank you, participants.
Thank you. Thank you. Thank you so much, Ram. Ram is a very, very practical gentleman. We recall with thanks the leadership of Ram. We had an opportunity to visit the Sriharikota launch pad last week on 20th August. Explore the space, organized a study tour to Sriharikota, which is the ISRO's launch pad in Andhra Pradesh. It's about 95 kilometers from Chennai. We had a great time there, and Ram was a key person who put that together for us. Thank you, Ram. Thank you for being with us there. Now, dear participants, I have pleasure in welcoming Mr. Tim Dyer, our next presenter. Tim has been a great friend and motivator of Explore the Space. Tim is the Executive Director of Fralock USA. Tim is an industry leader in advanced materials and components for aerospace applications. He plays a key role in bridging research and commercial solutions for the space industry. Over to you, Tim.
All right, thanks, TV. Thanks to everyone for inviting me, Ms. Ramsani and JD, and also for having Subhash and Amir here from UC Davis. I do a lot of work with UC Davis. I'm on their academic advisory board. So, I graduated there in 1992, over 30 years ago, I guess, and still involved with the schools because that's part of academia and industry. You never can really be separated. So I'm going to share some slides here. Let me see if I can share my screen if you can see it. Just explain a little bit about Fralock, so you understand who Fralock is, the company, and then just where I'm coming from and all of this. So I work as executive director of engineering, and I have my bachelor's degree and master's degree in material science from UC Davis, and that was in like 1992. So that's a long time ago. And I worked with Subhash Rizbud. He was my thesis advisor at the time. And since then, I've become more of a ceramist, material scientist, working in a variety of industries. And I currently am executive director for Fralock. Fralock is an engineered solutions provider of materials for a variety of applications that are semiconductor, medical, and aerospace. So this kind of shows it. So this is like, if you're looking at industry and companies you want to internship at, this is an example of a type of company that you'd want to. We have a lot of different products and a lot of people. Got 700 people. My engineering team's about 20, dispersed around the state of California. And we do all sorts of stuff, but we mostly make ceramics in my division. A little thing about Fralock Solutions is the space economy has a lot of different things around it. And this is just a material science segment. And when I talk about internships, and the next slide is really, so problems are solved by a combination of talents. It's never just one talent. There's no one sword or no one weapon that helps you win the battle. It's always a group of people with different skills and complementary skills and complementary thought that actually creates solutions. And I think in general, it takes a diversity of age diversity and thought diversity, ethnic diversities, create the strongest teams for solving problems. So in order for us as a civilization to prosper, we really have to collaborate and come together. And we're the strongest in that way. So Fralock, we're a materials company. We do advanced ceramics like aluminum nitride heaters, which heat up 300 degrees C per second. We have thermal interface materials when you want to clamp things together. If you want to move heat from one thing to the other in space, it's vacuum. So you have to push things together and use materials that conduct heat to move heat either into or out of the device. And also, if you're going to be in outer space, things have to be flexible. It's cold. So you need polymers and different materials that stay flexible so the solar panel can unveil and you can get power, or you can have that umbilical that connects to the worker who's out fixing the spacecraft, or you're running that digital printer, that 3D printer that's going to be making things. They all require these flexible materials. Now, the first part, and I know there was a lot of discussion by Mrs. Ramaswamy about the the internships, but this kind of summarizes my view of internships and kind of how you can, as a young person, get involved with industries and become a better engineer outside of academia. So this is the industrial perspective, that the goal is to develop teamwork and communication experience by collaborating with multiple engineering disciplines. In academia, you could be with a whole bunch of mechanical engineers or with your electrical engineers, but honestly, the solution is going to come from a mixture of different disciplines, and working in an internship allows you to be exposed to these other disciplines, and you learn how to communicate with them and collaborate, because you're much stronger when you work with different people, different types of thoughts. So different ways that you can get this experience, like internships are great, and if you can get one, it is so valuable. It's the gold of the career. It can even help you determine whether you want to be what you want to be. Maybe you're a mechanical engineer and just like, oh, I'm not interested in that. I want to become an aerospace engineer. Or maybe I like material science. I'll pick that up because I think it's kind of interesting. It's like chemistry, but it's fun. The internship helps you make the decision. So summer work internships are great. Keep in mind, there are also longer term deployments you could have with industry we call co-op, where you can take a semester off and you got to work with your professors and make sure that it's compatible with your schooling. But it's a great way to get a deeper experience in an internship. So co-ops are available. Both internships and co-ops, I've hired students from both permanently for my company. So they do lead the jobs. 100% is correct. Other ways to get experience, campus clubs. There are a lot of, like Egg Drop, we had material science club. There's electric car, there's solar vehicle clubs. There's a lot of clubs on campus. I know the material science club, UC Davis, makes these magic shows. They got to do some phenomenal stuff, which is very fun. So you can actually enjoy working with other people. Industrial mentorship. I know UC Davis has mentorship programs that they can offer. You talk to university, or if you know of someone who has a parent or somebody that can help you. It's really important for a young person to have someone to help give them some guidance and mentorship to kind of discuss the challenges of being a young engineer. It's not easy. It's not an easy road. And finding someone that may be in the field of your choosing could help you evolve. And then there's this, I said, the old-fashioned volunteer projects. I did a lot of these when I was growing up. I built a play yard for students with a community. You can work with your school, your church. Maybe you have a big family. You guys are going to build a house. You want to do some work. Taking a role in a family project to help out, to be practical or use some of your engineering skills is a great way to give back. And also, maybe you work with the neighborhood. Again, it doesn't have to be experience in an industrial setting. I've seen resumes where people have done church or community work or even school work. That is very valid experience. Again, internship is the greatest thing if you could hook it, or a co-op. But honestly, if it doesn't work out, there's still other ways that you could really contribute, learn how to work with each other, and kind of really improve yourself, becoming not just an academic, but more of a well-rounded person in terms of engineers. So I'm going to go ahead and stop that. And I know that we're tight on time, but that's at least the industrial perspective from Tim. So thanks, Stevie.
Thank you. Thank you so much, Tim. We particularly appreciate your mention about volunteer projects, where you mentioned church, community, family, and school. I think, Tim, that is very, very important when a student develops a grounded personality and evolves as one complete human being. Thank you so much for the mention of volunteer projects. Thanks again, Tim. Participants, now we request Professor Amir Saeedi, Assistant Professor, Department of Material Science and Engineering, UC Davis College of Engineering, for his presentation. Amir, please.
Thank you so much for the introduction and invitation. So I'm coming from academia, so I'm sharing my perspective from this side. So I'm instructor of a course which is called Senior Design, or in some universities, Capstone Project, which was formed around the year 2000 when the industry realized that the students who are graduating from school, even with good GPAs, high GPAs, they don't perform as well as it's expected. So, and the disconnection was that the students learn the knowledge, they know stuff, but they never really applied that on real world projects. So it's easy to find a solution on a piece of paper using equations, but in real world, there are some other constraints, availability of the materials, costs, manufacturing processes. So to address this disconnect, in engineering majors, they changed the curriculum and added a course which was senior design. And basically the idea is that the students work on a real world project and find a solution to the project that is offered ideally from industry or from research in other professors' labs. So, and this course has been evolved in this university and our department. From the beginning, we had project from industry, and it used to be a 1 quarter class. We are in a quarter system, so students were working on a project for 3 months. That evolved to be a 2 quarter class, and now it's a 3 quarter class. The whole academic year, the students work on a project. So we had 7 sponsors last year. One of them, Freylock. Our students worked under Mr. Dyer's supervision. And again, the idea is that the students develop skills. So they already know the knowledge, how to apply that knowledge. They should work within the constraints. Project management skills. These are skills that we don't teach, at least explicitly, in our courses. And working on a project within a team under supervision of someone who is experienced allows the students to work under a budget. They have clear idea about the deliverables that they have. They learn about the resources that they have available to them in the company that they are working for or inside the university. So they should prioritize tasks so that they meet deadlines. So these are all the skills, management skills that they develop during this project. Again, they are working in a team. Teamwork, collaboration becomes a key aspect of the project. So there are lots of conflict that can arise during the process. The students learn how to resolve those conflicts. Classroom is a safe environment. So, and these all become skills that they develop that they can apply later when they go to industry and have a real job. They learn about industry-relevant tools and technologies and professional communication. One aspect of the class is writing reports weekly and having update presentations, again, weekly. So it makes the students, it shows that the students are responsible and can work within constraints, time constraints, meeting the deadlines, and also enhances their communication skills. So writing a report, what they had planned to do during the previous week, what they have achieved and what they did not achieve and why. What were the roadblocks and what are the solutions that they're anticipating for those roadblocks. And whether the mentor from industry or me as an instructor can help them to address those issues. So something else is that industry expectations are different from classroom expectations, and working with someone from industry exposes them to those expectations. So as was mentioned by Dr. Ramsamy, so they can sorry, in their interactions, they can show that the professionalism, that they can work under stress and meet the deadlines. Those are the skills that are valued by the industries, and they get to be exposed to those during these interactions. Again, as was mentioned previously, they can develop their portfolio. When they go to an interview, they can talk about the project that they did in this class. So it's a 9-month project. They work within a team. They work under supervision of a professional. And those all can be valuable experiences that they can share during their interview processes. And some other aspect is that we emphasize a lot on standards and certifications. So the students, when they find a solution, they should find a kind of standards. For example, in our major ASTM standards is something that they're exposed to, so that they can standardize their approach, their solution, and can be kind of uniform so that they can communicate with others who are in the field. So these are some things that we hope our students to develop by doing a project in our class, in this type of class. And that's the solution that academia had to bridge the gap between industry expectations and the students' preparedness. With that, I'll have Dr. Rizbat to continue the conversation.
Thank you. Thank you, Amir. Thank you so much for your emphasis on professional communication. We all understand and we all believe that that's the most important thing. Particularly, it will be very good if the students can pay a little more attention and develop their professional communication skills. Thank you so much, Amir. Participants, now we have Professor Subhash Rizbud. Professor Subhash Rizbud is Distinguished Professor Emeritus, Material Science and Engineering, UC Davis College of Engineering, United States of America. Professor Rizbud is a renowned academic with decades of experience in material science and research. Professor Rizbud has contributed immensely to the advancement in high-performance materials critical to aerospace and space exploration. Professor Rizbud, I cannot thank you enough for giving time for us, and thank you so much for joining this webinar today. Over to you, Professor Subhash Rizbud.
All right. Well, thank you, DV, and thank you all of you that have spoken before me. I've, of course, known most of you for a long time. Tim and I go back, as he said, to a long time ago in the early 90s, and then Amir and I have been speaking off and on ever since he arrived here a few years ago. So, I think a lot of what has been said I agree with. And I've said this often before, that in the 9 or so years I spent as the director of our Internship and Career Center at UC Davis, which is a big organization of about 30 staff people, I was quite amazed to know that internships go beyond just science and engineering. I mean, when I look at what we just talked about, well, of course, we're interested in space-related internships and all of that. But then to my absolute astonishment, in 2006-07 timeframe, I found out that for many, many, many years, UC Davis has sent 6,000 interns worldwide. And that includes NASA, Ames, JPL, Pasadena, you name it in the space context, but also everywhere else. And so my feeling here is that as much as we want to talk about exploring the space and, shuttle tiles and Freylock and ceramics, which are my, first love, of course, in materials, I think we still need to keep our mind open to the fact that there are other possibilities. And Amir explained the senior design project things that began here at UC Davis in the late 90s, 2000 timeframe. And for many, many years, we were just sort of sticking to one company. Hewlett-Packard was the one, and Tim might remember that. So all the people in the senior design course would only work with one company. And then as we went along, we started graduating, and Tim brought in Freylock and then a few other companies. So we went from 1 to maybe 3 or 4 for a while when I was teaching the senior design course, and Amir has taken that to the next step now of many more companies coming in. So I think this expansion is very important. But the point I'm making is that at the bottom of it all, and I think Mr. Ramaswamy said this earlier, and Jaideep too, that what I want to see my students learn is, first of all, how to work in a team. And I think Tim made that point very eloquently. And also the team spirit. The Capstone Design Project is a bunch of 3 or 4 students who are working together on one thing. And in that process, since they don't know each other before, they develop people skills, which I think is probably the most single important thing here in the world. People skills first, and then technical stuff comes and goes. So, and as Jaideep pointed out a while ago, things become obsolete in 3 to 5 years, then you got to learn new things and meet new people again. And so all that stuff ought to be taught at the college level. And I'm teaching a freshman seminar this summer session and next year also on how to develop and enhance communication skills with your student colleagues, your faculty, and other people on campus. The one I'm teaching right now is for high school students who are just going to start a freshman year. It's a 6-week course. And I'm surprised to find that nobody's really told them that, well, you need to talk to the person you meet for dinner at your dorm, and not just sit in a corner in a table somewhere. And those kinds of little things, until you bring them out into people's knowledge base, or at least awareness base, it just seems like we're only talking about, organic chemistry, physics, math, and all of that. That happens. But I think this people skill part, I feel, is extremely important. And to my absolute astonishment, I ran into a person at the Memorial Union on campus, and Tim remembers this well, as does Amir, where we have, coffee shops and dinner and all of that. And I ran into a student who just arrived here from Cornell. She was joining her husband, who's a mechanical engineering student, and she got a degree in what she called psychology and cognitive science at Cornell. And I first looked at her and I said, well, what do I have to do with it? And then, to my absolute surprise, and I don't know how many of you heard this, there is a connection of material science to cognitive science and psychology. And not that she made it up. She showed me published papers on this subject in very notable journals, which talks about the marriage of material science and cognitive science. And we are now just about in the process of submitting a proposal to the Sony Foundation for a faculty innovation grant, where she talks about how there is a visual perception across the human sensing and materials interface. And so this applies to autism, diseases of disabled children and so forth. And I became so aware of the fact that I've been so blind to this. All these years I've been in the profession, I only thought of, well, what's the next best ceramics for shuttle tiles? Mullite is a long time back. Now let's get some other one. And NASA Ames has already developed mullite tiles, and I'm sure Jaideep's research labs have developed other ceramics, and all that is going on. Freylock is developing new yttria magnesia ceramics for companies that Tim and I are working with, and we're doing spark plasma sintering. All that is fantastic. But is there a tactile and visual perception of a material that we are simply unaware of? I mean, every day we put on a shirt, we eat on a plate, it could be plastic, it could be glass, it could be a ceramic, and we're totally unconscious that me touching a piece of glass while drinking my tea is different in my brain than an autistic child touching it. And Simran, the woman who I met from Cornell, who had just come here about a month ago, told me, well, there is published literature on this. Autistic children apparently perceive things in a completely different way, and it's a field of study that's wide open. So I wonder, we were talking about water being found in, outer space somewhere. The first person who touches that water, if it were me, I'll perceive of it differently. Ice is what Jaideep said, right? Yeah. So if you touch that piece of ice, is it cold, hot? That I know. But is it soft? Is it hard? Is it smooth? All of those psychological and cognitive factors connected to a specific material surface are matters of tremendous interest and have published literature on it, which most of us in science and engineering, including me, have never even heard of. So I'm saying that when we look for interns, we need to give them a much broader spectrum. It may be still space focused. Okay, fine, that's wonderful. But within that space focus, there's a human sensing element, there's an element of visual and tactile perception. All these terms have become very new to me in just the last 4 weeks because of this MS master's student. She got a master's at Cornell. And so I'm sort of saying, all is great. Everything we talked about, expanding companies, and what Amir said about going and getting more senior design projects. Could there be one that a company wants to fund for an undergrad or even a recent grad on and outside the UC Davis apparatus? Because our Department of Material Science, which I don't want to be critical of, is somewhat narrow-minded in that sense. We focus on one, and that's just as well, because that's how you get grants and this and this and this. But to increase the breadth of this, we need to think beyond what we've been traditionally doing. I mean, when I came to the United States at Berkeley many years ago, metallurgy was the big thing. Metals was the only thing everybody was talking about. Earl Parker at Berkeley and all of the people. Then I went to Stanford and we did crystal growth, and yeah, everybody's talking about semiconductors and silicon and blah, 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 blah. But nobody thinks of other things beyond outside this. I mean, you're thinking about people are building a wall. I mean, what is the wall made of? And then there's hemp and there's other stuff that the wall is made of. It's a new concept. I want to put it under the umbrella of a new concept. New, by which I mean not new material. New material is fine too. But the new concept is, how is that material used? How is it made? How is it used? How is it disposed? And all of them, the environmental aspects of space science, all of those things. So maybe I've overstepped the boundary here a bit, but I kind of feel nowadays that as I approach, 40 or 50 years of professional life, that there's a whole part of the football field I've never even looked at. I was so focused on the center part of it or the goal post that I never saw the other side or even the sidelines and what is beyond the sidelines. And maybe there is something very rich and valuable there. Maybe it's an outer space, maybe it is not. And so, all of these things. I sort of thought I'd throw these ideas out because they've been going through my mind. And certainly anybody who's interested in talking about it, maybe Tim and I can have a separate conversation since he's so close to my location at Davis, and Amir and I as well, on whether there is a possibility. And, we're hoping this Sony thing will come, but, that takes a year before they review anything. But I'm sort of saying human sensing and perception and materials of different sorts, there's an interface there that has largely remained unexplored by us in the field of science and engineering, while the psychologists have talked about it and thought about it and published about it, and we have ignored that literature. So with that sort of rash entry into this, I will stop. Thank you.
Thank you. Thank you so much, Professor Subhash Risbut. Your emphasis on teamwork and team spirit and the importance of knowing more about materials is very striking. And we only wish that we could do more. And we certainly wish that we could work with you at a more closer level and at a more continuous basis. We look forward for that, Professor Subhash Risbut.
Yeah, I'd love to do that as well. Thanks, Stevie. Yeah.
Thank you. Thank you. Now, dear panelists and dear participants, we now go to the discussion mode. I have two questions. Question number one, what are the resources that the panelists, beginning from Jaideep, would like to share for students worldwide? There are a couple of students from the United States, but a large number of the participants are from India. So my request and my question is, what are the resources or information that you would like to share to the worldwide audience, including United States of America, but not restricted to United States of America? That's question number one. Question number two, well, not all students score a 10 on 10. I was never able to do that. We have students scoring 9. We have students scoring 8, 8 on 10, 7 on 10, 6 on 10, and perhaps even lesser than that. I would not like to argue that all students are same. The students who score more are certainly the ones who pay more attention and who work harder. Then a large number of students score 7 on 10 or less than that. Now, how do they get internships? What is it that they should be doing in the classroom or in the college? Particularly students who score 7 on 10 or 6 on 10 or lesser than that, so that they get the attention of companies. So those are my two questions. With that, may I request Jaideep's inputs, please. Over to you, Jaideep.
Okay, because we don't have a lot of time, there are numerous opportunities for students. The main thing that I do with my organization is provide these opportunities to students. Now, they are mostly based on NASA competitions. So NASA has competitions like Lunabotics, where students build a rover that has to be driven on an artificial lunar regolith lunar soil and excavate. This used to be a worldwide program, but for the last few years, they have made it only a United States program. Then there's a student launch initiative where students can build rockets. There's something called the Human Rover Challenge, which I think is open worldwide. It's at the Marshall Space Flight Center. It's about you designing a human-driven bike. There has to be two people, a man and a woman, riding it, but the terrain is very uneven. Worldwide, at least from what I know, I have some programs which are mostly geared towards high school students. One of them is a new program we have done, and it's worldwide. It's called Plant the Moon Challenge. And if I can just share my screen 1 second, I'll show you quickly.
Yeah, yes, please.
But this is something that that you can do in India. Okay. So let me just quickly do. It's called Plant the Moon Challenge, and it is there it is. So at the University of Central Florida, where I'm located, we have a lab which actually manufactures artificial lunar and Martian soil. Okay, and we have a big bin where we can test rovers and wheels, and people from across the world are coming to us to test the rovers, test the wheels of the rovers. But we went one step ahead, and as Professor Schwarz said, that don't restrict yourself to the fields that are directly connected with space. Here now we're thinking of agriculture. Okay, so now we're thinking, how can we make students figure out a way to grow plants on this artificial lunar and Martian regolith? Remember, they have no nutrients. Okay, these are crushed rocks that we have manufactured using rocks on the Earth, but they mimic the lunar and Martian soil. Now, we are encouraging students to grow plants. We don't tell them what to do, what plants to grow, how much light, but we have opened a new field. And now I'm working with schools in rural areas who are so excited about this. And there are schools in India and colleges in India who have taken part in this project. And two of them were winners. Let me show you that slide here. Yeah. So this Plant the Moon Challenge, the worldwide challenge, there were two teams from VIT, I think somewhere in southern India, Vellore. Okay, so they won the international prize on experimental design and on innovation. And for the experimental design, that's enhancing basil cultivation, tulsi, in Martian regolith using biofertilizers and organic amendments. So this is not just for school kids. College kids can take part in this project. So that's one thing which is open to anyone across the world. The other one is we use the same material and try to figure out a way to come up with a concrete mixture from where you can build bricks. With the bricks, you can build walls. Why do you want to do that? Is because we want to go to the moon. Everyone wants to go to the moon. Everyone wants to go and land on the moon. The problem is the lunar regolith is so fine, and when you land, it disperses material to large distances. So we need to have landing pads now. Forget launch pads. We need to have landing pads. We don't want to carry landing pad materials from here. We want to use material on the moon to create the mixture and build the pads, build the bricks, so the bricks build the wall. So at this stage, we are challenging high school students to come up with a mixture, given the material we provide, figure out how strong it is, and then design your own lunar architecture. I can give you the slides, DV, and you can give it to the students. But you develop a regolith concrete mixture, construction capabilities, and design a lunar habitat. So, and we get all the project guides. We have an advisory board made up of NASA scientists and university folks. Here's some pictures of the bricks that students have built. Remember, these are like 5th standard to 12th standard students have done this. It's pretty amazing. They're trying to figure out how strong they are. They're trying to use that to build a wall and so on. But here's the cost. So it's not cheap. For a kit, for high school students, is $230, and there are 5 students per team. But if you go to smaller, if you go to 5th, 6th, 7th standard students, you can have one kit for a whole classroom. So this is the cost. And one thing that can be done in India, and when I come to India, we'll discuss it, is to get sponsors to pay for this. They'll ship it to any school in the world. That's one thing, challenge thing. The other thing is something called Radio Joe. Or before I go that, this is a NASA challenge which is open worldwide. Okay, and it's you can go to the website. It's Space Application Challenge, and you don't have to come to the United States. You do it in your hometown, and then they look at your results and you can win a challenge. But this is open to anyone. Last year they had 450 events worldwide. So this is something that is open to anyone. But anything that you do, we're talking about internship, which is one way of you to figuring out what the outside world is. But before you even become an intern, you start doing small multidisciplinary projects. That is very, very important. Not just stick with physics or chemistry or mechanical engineering, but work on projects which are multidisciplinary. In the real world, now I'm giving you because I'm talking about NASA and space. That's my perspective. But in the NASA world, any mission that you do is led by science. You want to search for water on the moon, or you want to extract ice. But who does most of the work? The engineers. They're the ones who are building the machines, they're the ones building the instruments. So you need to work on projects that have scientists and budding scientists and engineers working together. Another thing we can do at DB in India is, which I've talked about in the past, is building payloads for balloon launches. Such 5 days ago, I had 14 students from 6 universities come together, freshmen to grad students. They all came for 5 days, and they designed and built a payload, and we launched the weather balloon, and we got data. Along with a video of looking at the Earth from 100,000 feet, we got data. Now, this can be done anywhere, okay? And I know they do balloon launches in India. We just need to have to figure out a way that it can be done nationally and have a program where you can build these payloads. Communication is very simple. And there are lots more. I think the best thing what I can do is to give you the slides, and you can actually give it to the students. But what was the second question? There's one thing I wanted to answer about the second question.
Jaideep, my second question was, how do students who score 7 on 10, 6 on 10 or less than that impress companies and they seek internships?
Yeah, so again, this is my NASA point of view, okay? And again, I'm working with industry. I do work with companies. They don't give a damn about your score. They don't care if you have, here we call it 4.0 GPA. In India, 100 of 100, 90 of 100. They don't care about that. They care whether you have worked together in a group, multidisciplinary and things like that. The problem in India is, and I could be wrong, is the competition. There are so many students, okay? So unless you get 110 out of 100, you're not a good student. And I'm totally against it, okay? I do not care if a student gets 10 out of 10. But how do you convince a student that when they get a 7 out of 10, 8 out of 10, don't be disheartened, okay? Because you are a very good student. Testing does not show you how smart you are, okay? So don't give up. Just because you got a 7 out of 10, don't give up. You want to do something, you stick with it. I have seen students who have been rejected 2 or 3 times. They have not given up. They do it. And finally, I want to say something which I'm so impressed. I see this is 5 o'clock in the morning in
Yes.
India, and I see about 20 students. And I'm addressing these 20 students. You are going to go places. I guarantee you that. Someone was taking the time to get up at 5 in the morning and listen to us old folks talk, it means you have some drive. So don't give up, even if you don't think you're. I tell you, when I look at applications from students nationwide, I don't care about their, the scores. I care how they write. So someone was talking about communications. Apart from communications, the writing skills is so important. Don't rely on chat gpt. Okay, now I get all these essays where they're using chat gpt, and I can figure it out. It's not their own words. Okay, and companies are now trying to figure out various ways of looking at applications where they want to see that you're not using chat gpt. So apart from communication, writing skills are very, very important. I'll stop here because you have other panelists to talk about.
Thank you. Thank you very much, Jaideep. That was very, very encouraging. May I request Ram for your inputs, please? Mr. Ramaswamy, please.
Yeah, I received a couple of questions from the students who are participating in this seminar.
Yes,
they asked about, do I need to do an internship in my specific field of study? That's one of the questions. I would like to answer them as it is beneficial to get an internship that align with your field of study, but it is always necessary that some internships can provide you with the transferable skills that are valuable across various industries. So it's about the experience and the competencies you gain out of the internship. Don't worry about the field of specific field, but you gain the other transferable values. Another question I got is, what if I do an internship and realize this career is not meant for me? That's a question. Suppose you are taking an internship and you are not pursuing that, may not be the field of interest when you start doing that. My answer is, internships can confirm your passion or help you to pivot something that is better fit. It is a learning experience anyhow that adds to your professional journey regardless of the outcome. So don't worry about that. Whatever internship you get that and do the outcome of the things which are positive for you, which can build your things. And I want to tell the opportunities that are available in India on internship opportunities. Just to give a gist, top companies like Infosys have got programs InStep, Wintership, Infosys Summer Internship, like that, and they select interns to work on live projects, receive mentorship, and gain certification. You are having that possibility. And TCS also provides industrial R&D technology consulting. Microsoft India Development Center offers internship on actual projects. IBM gives in various fields, technology, consulting, and research. Startups and other opportunities are providing that. Make Intern, it's offer in various fields, including marketing, sales, HR, and other things. AICTE National Portal, it provides a platform for students to find internships in various fields and industries across India. And especially when we talk about space industry, let me give you some flyers because we are talking about space now. This webinar is on that. Indian Space Research Organization offers internships in various centers and units, including Vikram Sarabhai Space Center, Liquid Propulsion System Center, National Remote Sensing Center. Interns can work on projects related to space research and technology, and enhancing students' involvement in space industry through internship and competitions about Indian scenario. In 2023, ISRO received 2 lakh students internship requests, but accommodated only 2,500. Expanding structured program can ensure at least 10% of the participation, promoting real-time project experience. And there are more than 100 plus space tech startups in India as of last year, 2024. Student industry collaboration through sponsored competition can enhance employability, generating skilled manpower for upcoming missions. 85% of the Indian students prefer IT careers over aerospace due to limited awareness. So we have to make awareness to the students that Indian space market is projected to reach 13 billions by 2025, by end of this year. Students-driven innovation challenges can directly feed into this sector. ISRO's Young Scientist Program engages 150 students yearly, but India has got 260 million students. So we have to see that. So we have to get to the tier 2, tier 3 cities. This is where the explore the space will come into the picture. This webinar itself is a starting point for the students. We need to explore the certificate course offered by the Explore Space, so that as a first step to get into the space, which is very well designed to suit our needs. The students should get into these kind of things so that they can get better internship opportunities. And by 2030, India will require over 50,000 professionals in space tech and satellite sectors. So when we have all these factors into the things, the students should look forward, should open their eyes and ears to the opportunities which are thrown upon them. So I think as an NGO, you can be a bridge to be used to fly into the space for the students. So thanks for the opportunity. Thank you.
Thank you, Ram. You nailed it when you said that ISRO receives 2 lakhs and is able to accommodate less than 10%. That means there is a huge demand for more and more structured internships. That's where organizations, non-government entities like Explore the Space can play a much bigger role, and we are looking forward for that. May I now request our good friend Tim for your comments, please.
All right, I'll just keep this quick. I guess we're supposed to give the students something that'll help benefit them, and then also talk about academic performance. I think one of the most important things, and you could get it probably from working either with, again, local community, family, clubs, is what I call is structured problem solving. And you can find this in YouTube. There's videos on this, and people call it brainstorming sessions, but it's to get a group of people together of different types of personalities and to have a common goal, a very clearly defined goal, a problem, and you work together to solve it. And when you deal with different personalities, there's a lot of, I'd say, soft skills that are required to get people to work together. Some people are very introverted, so they don't want to say something. So maybe they want to actually write a submission. Some people are very talkative and they kind of dominate the show. And as a moderator or a person in the brainstorming session, you really can't tell people not to say something. You can't quiet them down, but you could actually try and coach them to say, let other people talk, because some people are shy. And then one of the skills I find most valuable in brainstorming sessions is I'm a guy that builds stuff out of like coffee cups and paper. I'll actually construct a prototype to get people to see what you're thinking. Now, the key is keep this in mind with brainstorming, is there's no one solution idea. No one's going to have the solution. Everything's a partial solution. But the good news is if you get enough partial solutions together and you connect them together, you get a full solution. That's why you need everyone's help. And getting people to think and getting them motivated and understanding that everyone has a different way of viewing things. Everyone has a different perspective. You need to mix it up. Papers, colors, you could even get magazine pages or pictures. You could look on the internet to kind of inspire people, textures. All this stuff will get people thinking to create what I call half-baked ideas. And then the half-baked ideas, when put together, actually become fully baked solutions. And everyone contributes. So this is really how you leverage people. So structured problem solving, very important. And then my advice for people who don't score well on tests, and being in the industry for 25, 30 years, it doesn't really make a big difference. But what I can say, what does show you is if you stick it out and you get your degree and you haven't always get good grades, that means when the times are tough, you keep going. And that is so important, because engineering is not always easy. And you get kicked, you'll get pushed, the answers won't come, you'll be tired, you'll have failures, things won't work out. That is just normal. You don't always score A, but in the end, you'll have a good solution and you'll feel confident. And that's really what makes you feel good, is to find the solution, to solve the problem, have the happy customer, the spaceship flies, that's all right. Expect things to be tough. I gotta say, that's just normal. And good grades are just indicate that maybe you're lucky in some ways. You can't always rely on luck. So that's my contribution is poor grades just means that if you stuck out to your degree, you're tough and you have the muscle that it would take to actually help solve problems in industry. So I got it. Thanks.
Thank you so much, Tim. Thank you for your emphasis on getting connected, teamwork, and keep doing. That's your message. Thanks for that. May I now request Professor Amir for your inputs, please.
So, so here at UC Davis, so to answer the first question, how to find opportunities for internship, we have a career center, Dr. Rizbad mentioned. So that's one place that the students can reach out to. But other than that, so smart use of ChatGPT. So I also look for industries to partner with and to have projects. And I asked we had project on ceramics in class. I wanted more projects on metals for my class. So I asked ChatGPT where I live, what are the companies who are focused on this type of material? And it listed several companies, and I believe the same thing can be done. Find what you're interested in. So again, I'm material science and engineering field. And for example, I'm interested in ceramics. I'm interested in manufacturing. I'm interested in characterization. What is that I'm interested in? And then maybe I can use tools such as ChatGPT and ask, okay, I'm interested in this specific topic. What are the companies around me that offer internship, okay? Or maybe just what are the companies around me that have work on this area? And then the list that it provides, you can go through them one by one and see if they provide any opportunities. So use such technologies in a smart way. Don't use them for writing, but these are some benefits of those tools. That's one thing. The other question was about the students who don't necessarily have high GPAs. So GPA is important. It makes things much easier for you. I don't want to say that's not important, but it doesn't mean that if you don't have a high GPA, that's end of the world. Last year, I had a student who didn't have particularly a high GPA, but he was heavily involved with clubs. And he built skills, technical skills and professional skills. And eventually he found a job at SpaceX, where many other students were not successful in securing positions. So your skills are valued. It's easier to showcase your skills if you have high GPA, but if not, being persistent and making connections with people, with professionals around you, that can make things much easier for you. So my suggestion is to work on your technical skills and soft skills.
Thank you. Thank you so much, Amir. Your emphasis is on keep working on technical skills and communication skills. Sure. Thanks for that. Points well taken. May I now request Professor Subhash Rizbud for your comments, please.
Okay, let me speak my mind frankly, on what I have experienced. I think as far as the first question is concerned, finding an internship, I guess almost everybody's addressed it. Amir pointed this out right now, looking for contacts and other, avenues for connecting to companies, and even sometimes within the universities and national labs around us, there are internships available that a lot of students don't even bother to apply for. We got Lawrence Berkeley Laboratory, Livermore, Sandia, Albuquerque, Los Alamos, and amongst the many small ones, and then of course NASA Ames and everything. So students don't know the breadth of what's available to them, so it's just making them aware. And of course our Career Center is just one unit, but I think in every one of our classes, including the senior design class, students should be made aware that these are the other possibilities. And then within the university, a lot of professors need interns within their research labs or, TAs and all kinds of possibilities. So I think the breadth of exploring those internships is one thing that students need to be made aware of relatively early, and beyond going to the Career Center alone, and just one-on-one contact with people around them and students and industry and Silicon Valley and all kinds of things like that. So that issue is one. And the other, of course, about the GPA, I totally agree with everybody who said the GPA is not the most important thing. I've seen probably some of the students with the lowest GPA, just barely passing GPA, 2.95 or 2.99 out of 4. And they've done wonderful things in the world. I mean, they've been so successful. My own graduate students who have finished their PhDs with GPAs of less than 3 sometimes, or very close to 3, have become entrepreneurs of their own, and they're funding companies. They're, doing great things in the world. So I think GPA has no proportionality constant that's linear to success at all. And I agree with what Tim said, that they're partial differential equation and they're very A plus B plus CX plus X squared and all of that. And so, the more you build connections with people and the people skills, the better the result. And the GPA has become almost irrelevant. I mean, it really, not even at the time of the interview do I think it's the most relevant. It's how you come across, the whole idea of an elevator speech and all of that. So I think I place virtually no emphasis on the GPA at all, or even exams. We have open book exams, we have oral exams, we have prelims, we have qualifying. They are really a very, very small fraction of the indicator of a person's success thing. I have sadly found in many situations quite recently that professors seem determined to fail their students rather than have them succeed. And I see that as a very peculiar UC Davis phenomena. Maybe I'm wrong about this. I hope I'm wrong. Amir can clarify that for me. But when I go to Stanford or when I go to Caltech or other schools or even Berkeley, professors want their students to succeed. And here we seem to want them to fail. And I don't understand that. I mean, Tim can speak to this perhaps, but when he was here, that wasn't the case. When Tim was here, we had Zuhair Munir and Mukherjee and all kinds of people who were determined to make their people succeed, not just their students, the whole department. Now, I find myself in the middle of people. I mean, I'm now retired and on recall, but I find myself sometimes, not everybody's like that, but overall, the collective thinking is, how can we impress them in such a way that we make them fail? You are not looking any better. You have also failed if your students have failed, is my view. My philosophy is that if your students have failed an exam, prelim or qualifying, then you have failed just as much. Because why didn't you tell them before the exam what to do? See, what I'm saying is that I have a tremendous problem with faculty trying to prove how smart they are and therefore try to fail the student, as if that were an indicator of how smart they are. So with that sort of a very nonlinear observation, I think I should stop.
Thank you so much, Professor Subhash Risbut. I note the emphasis on career center and resources within the university, because in my own experience, I feel that the largest repository of information or resources is always the university. Are the so many departments that are there in the university that can be of tremendous help to the students. Now, to the students here and the panelists, I would request your attention to a very, very small presentation that we have. This is about what we have developed. Is my screen visible? Is this screen visible, please?
Yeah,
now it is.
Yes.
Yeah, it is.
Thank you. Now, this is particularly for the students. Now, we have developed a digital online course. Thanks to Tim, when Tim was in Elcon. I also see Nikki, who has joined this. Hello to Nikki. So we have developed something called the Digital Certificate on Career Opportunities in Space and Allied Industries for college students. Though this has a lot of emphasis on what Indian students would require, a lot of inputs we have received from Tim, a lot of inputs from Jaideep sir, and over the years, we have including inputs from Professor Risbut and other friends. So this is a course that we would recommend the students to sign up. It covers evolution of modern space studies. It covers information on leading companies. And then it also talks about interview skills. The message that I would like to leave to the students is the name of the game is get connected and stay connected. So students, if you get connected and stay connected, bigger opportunities are just around the corner. So this is the presentation that I wanted to make. On those words, we welcome questions offline that we will send it to the panelists here. I would in particular like to recognize and thank Dr. Manoharan. Dr. Manoharan, the head of the Department of the Government College of Arts and Science in Vandavasi. Vandavasi is a real remote place from Chennai. Dr. Manoharan's college has shown interest in visiting Sriharikota, the rocket launch pad. A large number of students from Dr. Manoharan's college are from a rural background, are students from village. Hello to Dr. Manoharan. Thank you. Thank you for joining. And we look forward to working with you and taking your students to the rocket launch pad. On that note, my sincere thanks to Dr. Jaideep Mukherjee, Professor Subhash Visgood, Mr. Amir Saidi, and our good friend, Mr. Tim Dyer and Mr. Ramaswamy for joining this panel discussion and making it lively. As I mentioned, we'll be making a report of this and sharing it with agencies and companies, both in India as well as in the United States of America. And we look forward to working with you more closely. My sincere thanks to all the panelists and participants. Thank you, one and all.
Thank you, DV.
Yeah.
Thank you.
Thank you so much. Thank you all.
Thank you all.
Thank you, sir. Thank you.
Thank you.
Thank you, Jaideep.
Have a good day.
Thank you.